Now see here the current density. What is actually current density? So we have already done this relation I is equal to A N E V D, where V D is the drift velocity, I is the current, A is the area of cross section. If you write here I upon A, area I have taken here, that is N E V D. So actually here this I upon A is called current per unit area flowing through the conductor if the area is held normal to the current. So suppose the current carrying conductor is like this and you have taken this area, current is flowing I here to this side and area of this is A, I is the current, then we can write I upon A is called current density. So current per unit area is known as actually current density. Current density is a vector quantity and its direction is along the direction of the motion of the positive charges. So here we can write I upon A is here the current density. So we can write J is equal to N E V D, and we know the formula of the V D here N E E tau upon M. So we can write J is equal to N E square tau upon M into here E, and this is here we know it resistivity rho is equal to M upon N E square tau. So this will be equal to 1 upon rho. So we can take in this relation J is equal to 1 upon rho into E. But see here 1 upon rho is actually known as electrical conductivity. So 1 upon rho is represented by sigma and this is known as electrical conductivity. So we can write J is equal to sigma E. It is a vector quantity, so we can write J is here sigma E here. So this is about the current density, or you can say the relation between current density and here electrical conductivity and electric field. So now let us discuss here electrical conductivity and conductance. So first we will take here the conductance. Conductance is, that is written actually G is equal to 1 upon R, reciprocal of the resistance. Unit of the resistance is here ohm, so we can write here 1 upon ohm, and this is 1 upon ohm can be written mho, or we also called it here, this is Simon, that is written S. And electrical conductivity of the conductor can be written here sigma is equal to 1 upon rho is equal to, that is the, when you write the unit we can write 1 upon ohm into meter. So that can be written mho or m raised to power minus 1, or you can also write here as m raised to power minus n. S here stand for Simon. So this is about electrical conductivity and conductance. So now we have done the relation, also different relation. Now let us go for the limitations of the Ohm's law.